Hey guys, how you doing? This is video B in our series on covalent compounds. Today we're going to talk about naming them. And in a way, these I think, are pretty easy to name. So anyway, let's get into it. So binary molecules, binary means two. So these are molecules that consist of two atoms that share electrons. They're all going to end in IDE. Pin out. Let's shoot the red. They're all going to end in IDE. All right. Now, unlike the ionic compounds, each element will have a prefix that tells you how many atoms are present in the covalent compound. So let's look at some examples. So I got NO2. That name would be nitrogen dioxide. Okay, the di is the prefix that stands for two. So I got P2O5. This would be diphosphorus. Di means the two. Phosphorus, P. Pentoxide, or pentaoxide, right? Pentoxide. So that stands for the four. And on your formula sheets, you see where those prefixes are, and this is where we're going to start using them. All right. So if you look on this reference sheet, that's what I just talked about, you'll see some of these prefixes. You don't have to memorize them, but you will over time, right? So the atom with the lower electronegativity is usually written first. All right. If there's only one of the first atom, we don't use mono. All right, we don't use mono. So I've got carbon monoxide. All right, CO. If you know what that is, it comes from exhaust and it'll kill you if you suck it down. People commit suicide with exhaust for carbon monoxide. Anyway, CO is carbon monoxide. There's one carbon, it's in the front. If I don't put mono in there, we know that just means one carbon. So we wouldn't call it monocarbon monoxide. Carbon monoxide. Pretty easy. Now look at CO2. CO2. We would not call that monocarbon dioxide. It's just carbon dioxide. I think this will be all fine for you. Now the polyatomic ions, we talked about those last unit. Okay, there are two more atoms that are covalently bonded together, but they're not neutral. They have a charge, which is why they're an ion. So make sure you don't confuse those with the neutral covalent molecules. So this is nitrate. You know how to find those on your formula sheets. Nitrate is a polyatomic ion. It's got a charge of -1. -1. NO3 is different. NO3 is nitrogen trioxide by itself. See the 3 there? It's a neutral molecule. Notice it doesn't not in parentheses or brackets. It's different. Now let's answer some questions. Which of these will form a covalent bond? So we're looking with something with a electronegativity difference lower than 1.7. If I got lithium and neon, well, neon's not there, so it won't be that. Neon don't want to form a bond with anything. K, Br. 2.8 minus 0.8, nah, not that one. Carbon and oxygen, that's a 1. That looks pretty good. Put a check on there. And then sodium and chlorine, we know that's not going to form a covalent bond. And of course, the answer for that, go back. Let's find the answer. So the answer for that would be C, of course, carbon and oxygen. Okay, which of these will form a covalent bond? And that's lithium and chlorine. And we can tell real quick, that's a 3. Nope. Sodium and chlorine, yeah, we know that. Nope. Potassium and I don't know what FL is. Tricky question. So we get that one out. Hydrogen and oxygen. 3.5 minus 2.1. This is probably one of those special cases, 2.1 and 3.5. that would be a 1.3. Well, it's D, and a lot of this just knowing that H2O covalent, right? The bond with the least ionic character below would be, and this is the one with the least electronegativity difference. We got sodium and fluorine, that's a 3.1. That's pretty ionic. Carbon and fluorine, 2.5 and 4, that's a 1.5. It's covalent, but I don't know how much. Silicon and hydrogen, 1.8, that's a 0.3. Well, that's a very small number, so that's pretty not ionic. Okay, aluminum and oxygen. That aluminum is 1.5, 3.5. That is a 2.0 difference. That would have to be C. Let's check. And there we go. And again, it is C. 0.3 electronegativity difference. Very least ionic. So butter will melt on a hot day. That means is their intermolecular forces are not very strong. What type of compound is it? Metallic? No, that's got a high melting point. Ionic? That's got a high melting point. Covalent? No, very, very strong covalent bonds. Nope. Molecular? Yeah, that would be a D. And D it is. I knew that. You're given a substance that has a high melt point and does not conduct electricity even when you put it into water. What is it? Well, we knew from previous chapter that the ionic compounds will go into solution with their ions, so it will conduct electricity even with water. That's not it. You have a metal, and they will also conduct electricity, but they do have a high melt point. A molecule, I'm going to go with, let's see, I'm going to go with C. Yep. Molecule, well, it's got a low melt point. So that's what that one was, what it was. Chlorine monoxide. So that'd be a Cl. And one oxygen, that would be B. Pretty easy. I'm not even going to show the answer. Chlorine monoxide. Ooh, let's move this a little bit because I can't see it. So dinitrogen. Di stands for 2, so that would be an N2. Tetroxide. Tetra, I look at my sheet. That's 0.4. Okay, that's B. H2O. Don't say water. Dihydrogen, 1 oxygen monoxide. That's B. Let's look and see. I told you. All right, that's how you can tell your non-science friends what water is. Dihydrogen monoxide. Sulfur or SO3. There's sulfur, so it's not monosulfur. There's 3 oxygens. Well, trust me. These are actually pretty easy to name. So P4, that's tetra. Tetraphosphorus. Well, if you look under 10, it's dicoxide. That would be D. And that means there's 4 phosphorus atoms and 10 oxygen atoms. Magnesium, MgO, that's a trick question. Okay. Magnesium's got a very low electronegativity. Oxygen has a very high. That's going to be ionic. That's going to be C. And we don't want to call that magnesium monoxide, because that would suggest that it would be a covalent or a molecule. It's not. Okay, it's an ionic bond. Okay, guys, that's really all there is to naming. There's no Roman numerals. You use those prefixes and call it what it is. And it's a molecule. All right, so that's all we have for that. You guys have a great night, and we'll have video C out for you, 5C, here very, very shortly. So this is Coach Scott saying have a great evening.